Hello?
Hello.
Hello?
Hello.
Namaste. Not maste. Anyway, alright, there's a lot of crap here. Okay, so I'm gonna try and go through this quickly as I can, without losing anyone. Alright, we're gonna do volume, so we're rotating around the x-axis, y-axis, and lines that are parallel or perpendicular to the x-axis. Okay, so this one right here. So this is a cylinder. So the formula of a cylinder, or the volume of a cylinder. So the volume would be, okay. So it's going to be pi r squared times the height, right? Say yes.
Yes.
Yeah, that's the volume of a cylinder there. So volume of a cylinder, but for this one right here, okay, my r is just from here to here, right?
Yes, sir.
So it's the radius of the function. Okay, it's the radius of the function. It's to whatever line I have there. So it's going to be my f of x squared. My next one is going to be the height. The height is from here to here, right? So that's going to be from A to B, right? And the pi, which just commonly I always do it because I always factor this out beforehand because I don't want to mess with that pi. I put the pi in front. And then for what variable am I doing this? Dx. Right? In terms of x. So it's basically finding it in slices right here. Right there. Anyway. All the way around. So that's the whole thing. So whatever it is, so whatever my function is where I get that from. So the cone comes out to be exactly the same thing, but my function is, again, just whatever my radius is. Okay, here's another one where it's some type of wavy thing. Same thing, as I'm rotating around the x-axis, it's still going to be the same thing, where my thickness of my little pieces, little slices is my delta x. Okay, as I'm doing this, because each time I'm going through, it's in terms of x. And so have my function. Okay, find the volume of the solid of revolution generated by revolving the region around the bounded by the graph x-axis and x equals 5 about the x-axis. So now that I went all the way through that, so about the x-axis means it's going to rotate around the x-axis, right? Say yes. Okay, so it's about the x-axis. Okay, graph right here, x-axis, and the line x equals 5. So that means this doesn't go on forever, right? So right here, it's going to start, what are my bounds going to be? So if I'm talking about this, it's going to be the bounds from 0, right? It's bounded by the x-axis, isn't it? So in this function, it would be 0, wouldn't it? Okay, and what would be the upper bound? 5. My function is going to be square root of x, and what am I doing to that? Squaring it, and then dx, and put the pi out here. That's the whole thing, right? Did I confuse anyone? Did I lose anyone?
I think you lost Joe.
Huh?
No.
I lost Raquel?
No.
Come on, Raquel. Seriously, you need to pay attention. Did she shrink over break or something?
I just don't think she's here
Oh crap, she's not even there.
It's not
I'll tell her that during interviews.
Anyway, all right, let's go ahead and do the math here. So now, when I square the function, it's just going to give me x, right? Okay, so it's going to give me, so it's going to be x, so it's going to be pi 0, 5, x dx, so do the math, so it's going to be pi, bracket, so it's going to be x squared over 2 from 0 to 5. So it is, for this one right here, is it, I'm not going to have any bottom part of this, right? It's going to be minus 0, isn't it? So it's going to be, my answer is going to come out to be and if I was dealing with units, what units would I talk about on that one? Try again.
It's cubed. It's volume.
Volume. Volume is going to be cubed, right? Okay, so this is going to be
Guess on tonight's biggest
okay. There's a nice drawing of it, so you guys could actually see.
Oh wow.
Wow. Okay. Okay, here's another one. Bounded, region bounded right here. So there's my function. It's above and below. And as I rotate that, rotate around, it's the same equation. Going to be the same thing, but as I rotate it, it just closes the whole thing around. Okay, closes the whole thing around. So my function is not bounded by the x-axis in this case. All right, find the volume of the solid revolving of revolution generated by revolving the region bounded by the graph here, the x-axis, and the lines x equals -1 and x equals 2 about the x-axis. Okay, so that means that it's going to be just like that previous picture that I diagrammed. So my lower is going to be what? Upper. My function. And easy? Yeah. Okay. So let's see. This is going to turn into two to the 7th. I was almost there. I was like, ah, crap. I know 2 to the 5th is 32. 64, 128?
Yeah.
Yeah, so it's 128 over 7 minus a negative 1 over 7. So that's going to be, comes out with a total of 120, come on, 129 over 7 pi units cube. ¿Está muy fácil?
Muy fácil.
Muy fácil, muy fácil. All right, so here's the diagram of what that nasty thing's gonna look like, right? Yes, it is a stethoscope. Okay, so this method, use this method to find volume of a solid formed by revolving a region around the y-axis. Okay, so we're going to do this around the y-axis. So that means my function needs to be in terms of, thank you. So if I'm revolving on the y-axis, I have to have terms of, and I should end up with a d. Thank you.
Why?
You mean nay? All right. Use this method to find the volume of a solid revolution generated by revolving the region bounded by the graph of y equals x cubed, the y-axis, the lines y equals 1, y equals 8 about the y-axis. So that means about the y-axis, that means that this thing right here is going to be rotated around the y-axis. Okay, so same thing though, right? So that means that it's going to be from where to where? 1 to 8. And I'm going to put my pi out here. Okay, so now, I start off with y equals x cubed.
But you need to change that.
I need to change that. I needed to have a dy here, so this is going to turn into what?
The cube root of y.
Cube root of y. So that means y to the 1/3, right? Squared and dy.
Nice. I did the same.
I know, right? Okay.
I did the same thing.
Okay, so great minds think alike. All right, so this is going to end up becoming pi 1/8 y to the 2/3 dy pi, and that's going to be 3/5 y to the 5/3 from 1 to 8. Are we okay still? Okay, so let's see. This is going to come out to put my pi on the outside. Let me see. So cube root of 8 is 2. The 5th is 32. 32 times 3 is 96/5.
96/5.
And that's going to become a minus 3/5. So it's going to come up with a grand total of 93/5, 93 pi over 5, and that's going to be units cubed.
58.4.
Did I do my math right? Because I know that I kind of fast math at 96.
Well, it's 32 times 3, 96.
Yes.
Okay, good.
Yeah.
And it's 2 to the power of 5.
I know. And here's a diagram. Say, ooh, pretty.
Why is
Okay.
it only pink and blue?
I don't know, because the place I stole it from was only pink and blue. Be glad that you have any colors in here at all.
Yellow.
Washer!
There's your other colors.
Washer method. To find the volume of a solid formed by revolving region around the x-axis. So with the washer here is basically the outside minus the inside, right? Okay, good. Outside minus the inside. Again, outside minus the inside. Because I have two different radius. There is my donut over there. Okay, and here's my function again. So I have my outside area minus my inside area. And same bounds. Find the volume V, revolution generated by revolving region around the bounded of the graphs there and there about the x-axis. Okay, so this is bounded, right? Say yes.
Yeah.
Okay, so now it's going to be bounded somewhere, isn't it? So if they're bounded, what does that mean? They what? Yes, they do intersect. So it's bounded by each other, right? So I know that those two have to be,
That's fine.
say, equal.
Equal.
Thank you. So they're going to be equal. So it's going to be 2 over x equals 3 minus x multiplied by x. So it's 2 equals 3x minus x squared. So it's x squared minus 3x plus 2 equals 0. And let's go through and f that. So when I f that, I'm going to get, that's an x, it's a 1 and 2, isn't it? Yeah? Negative 1 and x minus 2. I'm kind of winging the math here and hoping it's working out.
It's working. It's working.
Okay, good. All right. So I'm bounded right there. So that means that it's going to be between 1 and 2, right?
Yeah.
Okay, good. So let's go through. So I am revolving this. So somewhere between 1 and 2, that I got to figure out which one has a greater value. Okay, because it's the outside minus the inside, right? So in between there, I got to figure out which ones, because they both at the ends are the same spot, right? So I just got to figure out which one's the outer. So let's go ahead and plug in 1.5. Or 3 halves. So if I plug in 3 halves, so that's going to be 2 over 3 halves, which is 2 over 1 times 2 over 3, which is 4/3. Okay, and the other one would be 3 minus 3 over 2. And so that's going to be 6 over 2 minus 3 over 2, which is 3 halves. And so that one would also equal a 6, so it's 9 over 6. And this one's going to be 8 over 6. Okay. Basic math, fractions.
3 minus x squared.
Yeah.
That's nice.
So that means that, which one? So the 3 minus x is the outer one, right?
Yes.
Okay, good. The 3 minus x comes out to be the greater of those. So I had to plug it in and actually do some basic. So it's going to be 3 minus x squared minus my 2 over x squared dx. Yes? Okay, good. I'm gonna do my math on the next page because I don't want to keep erasing everything. What was the function? 3 minus x. I'm sorry, I don't have it right here. Oh, dang it, it is.
Yeah.
Okay, 3 minus x squared minus 2 over x squared dx. Right? Yes, right? Good. All right, let's go ahead, square those. Okay, let's go ahead and square it. So, So when I square that, that's going to become 9 minus 6x plus x squared minus, this is going to become 4 over x squared. And then my dx. So I could do it all as one function like I did here, right? Okay, fundamental theory of calculus, I could break it up into 2 separates or just one big one, right? Okay, let's go ahead and do my integration for this one. So now it's going to, oh, can't forget your bounds. All right, so pi bracket, so that's going to be 9x minus 3x squared plus x cubed over 3 plus 4 over x from 1 to 2. Is everyone okay here? Did I make any mistakes? Hopefully I didn't.
No, you
Okay, good.
just understood by now.
Okay, did I lose anyone here? No? Okay, alright. So from here, let's go ahead and plug in. So this is going to be pi, that's going to be 18 minus 412, 8 over 3 plus 8 over 3 plus 2. That's all of this first one, minus the lower bound, which would be 9 minus 3 plus 1/3 and plus 4. Okay, so let's see. So as I distribute the negative, I'm going to change all those signs. So that would give me, let me see, this is, actually let's combine it first. Positive 6, positive 8. And that's going to become, let me see, that's positive 6, positive 10, negative 10. And that's going to be minus 1 over 3. So that is a negative 2. I have negative 2. And this is going to be a 7, so it's plus 7/3. So it's negative 6 over 3 plus 7. Positive 1/3 units cubed.
Yes.
Because that's a really, really tiny sliver, isn't it?
Yeah.
Yeah.
And we're taking that sliver and then we're rotating that around. So it's not going to get a very large volume out of that. Are we okay? I'm having fun with this. Yes, I'm enjoying this. Makes me happy. Okay, so we're going to stop there, and I'm going to finish the rest of this tomorrow. And tomorrow's, I believe, we're going to be doing the shifting of either parallel to the x-axis or perpendicular. All right, don't forget, like and subscribe.